Genau, das hat sich dann der Daniel hat sich dann geantwortet, weil ich habe meine private Adresse, da geht es so viel in Junk, ich muss das einmal ändern. Ja. Und wir haben jetzt die Möglichkeit, die Festgeber ist jetzt ziemlich eingeschlafen. Und das ist dann zum Schluss noch ausgelaufen, dass es immer nur quasi entweder bei der Bitmovin oder bei uns war. Und jetzt haben wir gesagt, okay, wir brauchen irgendwie was anderes. Und das ist für Aufnahme, das ist ganz bewusst, dass wir im Lakeside Talks Servus. Genau.
Die waren noch nie. Ich mag es mal so.
Ja, das passt schon.
Das passt schon, gell?
Genau. Du bist heute nicht. Du hast gesagt, du magst nicht so gerne.
Na, schauen wir, was wir für was noch bringen.
Danke, gell?
Ja,
die muss tatsächlich Argumentation mitliefern. Warum ist das jetzt?
Super Service. Wie geht's? Ja?
Na, danke. Mal schauen, was in das geht schon. Ja, das weiß ich selber nicht so genau.
Okay, optimal. Ja. Ah, es ist voll okay, dann kann ich da jetzt komplett in die Funktion einswitchen. Das ist super. Hallo, ich kenne ihn nicht. Bitte, Thomas. Ja, cool.
ganz kurz noch? Oder?
Du darfst. Was?
Ja, ich muss da in die Kamera schauen.
Achso, ja, ich lasse dir den Platz.
Was? Nein, ich warte noch auf.
Das Mikrofon ist links neben dir.
Ich weiß, aber das ist kein Problem, das nimmt das ohne Probleme auf. Ah.
Ja, da geht's jetzt mal los. Ja, eigentlich jetzt. Jetzt geht's los.
Ja, okay. Die Kamera sieht den Speaker. Okay, then hi and welcome you all to the second installment of the Lakeside Talks, and I'm really happy that you're all here, and I'm also welcoming our viewers over YouTube. Thank you for being here. I hope this is going to be an awesome event, and I hope we will have a couple of these events in the series, so stay tuned for the next ones as well. Today we're going to have two awesome talks. Both of them are on the topic of UI, to a certain extent at least. And I'm already welcoming our first speaker. If you could come here real quick, Lukas. So this is Lukas. He is software engineer at Bitmovin, and he will tell us about Compose. And I would say the stage is yours. And
thanks. You already took half of my talk. I wanted to introduce myself, and yeah, so that's gone already. Now, anyways, welcome everyone. Really cool to be here and to be here in person and have an in-person. Well, not everyone is here in person, but it's really cool to speak in front of a few people. Physically being here, really cool. Also, Veit, thanks for having me on this event, and thanks for approaching me to talk about this topic. Yeah, and that leads me to my topic, Compose. So the title is a bit, well, it's a big title, the future of Android UI and much more. I'm going to be very honest with you. It's not going to be that much more today because we just have a limited time. But I'm going to give you a bit of a sneak peek on why Compose is not just the thing for Android, but actually much more. Not going to look into the details, but just giving a quick overview. And yeah, it's a UI topic, but we're going to keep it pretty low-key, so I'm not going to go into a lot of detail because this is a very new thing actually. And I guess that not too many people, at least here in the room, from what I've heard up until now, have worked with Compose before or even Android, so let's really keep it kind of low-key here. Yeah, just a few sentences about myself. I'm a software engineer at Bitmovin at the moment, and I'm working in the Android team, which is a good thing, I guess, for that talk here. But I'm not working in the Android team as in I'm developing Android apps. I'm actually working in the player department, which means that we are developing a SDK for other developers. So we don't really provide a UI and we don't actually work on a UI, which leads me to the next point. So this is not something I do professionally. So this is my pet project, and I'm just really hyped about what Compose is and the opportunities that it actually provides to the community. So, well, not my actual profession, but still, I hope that I can give you a bit of an overview of what's going on there. Quick agenda, introduction, that one we more or less have already checked. Then we're going to talk a little bit about Kotlin. I don't know, quick question, did any one of you already work with Kotlin before? Oh, yeah, that's actually quite a lot of people. That's really cool to see. I planned to come here in a Kotlin t-shirt, but what unfortunately was in the laundry, so sorry about that. Yeah, then we'll look at what Compose actually is, what is it used for, and how does it work. And that how does it work is something that's actually, in my opinion, very interesting also for people who do not really care about UI development or don't do UI development themselves. So that should be interesting. And then we're going to have a little hands-on, and depending on well, how long it takes me to do all the theoretical stuff, this will be live coding, or I'll show you my cheat solution because I already prepared something, because live coding usually doesn't work. So yeah, that's the plan for today. Let's get started, I guess. What is Compose? So I put together a sentence that should give you the key points on what's going on in Compose. So Compose is a declarative reactive approach to create user interfaces with Kotlin on various different platforms. And all these words I'm going to explain to you now what it actually means and why they are all important. We are not going to start with the first word because that would be boring. We're actually going to start with the second to last words, but only after that slide. So Compose was actually developed by Google, and it was announced in like 2 years ago, 2019, on the I/O, Google I/O. So it's kind of a new thing, seeing it in the perspective of the lifetime of Android. And it's only in beta since February, so for 7 months ago, and it started, so the first stable version was actually just removed, just released 2 months ago. So it's really a new thing, and obviously there are a few people who are already very deep into the topic, but in general, developers are slowly getting interested and moving towards that new way of writing UI on Android. Okay, that now is where we start to look into the different words of this sentence, and we're going to focus on Kotlin for a little bit. So Kotlin, yeah, Kotlin is a programming language developed by JetBrains. That's the company that also does IntelliJ IDEA and all that great stuff that probably a lot of you know, at least if you're working in software development, software engineering. And it's actually one of the fastest growing programming languages. It's 10 years, so started in 2011, so 10 years. So they actually had an anniversary that year. And within these 10 years, they managed to develop a very rich ecosystem. So they have quite a lot to offer. Most people, if they know Kotlin, know it from mobile development. That is because Google actually made it the first, so the primary language on Android. I think something like 2 years ago, or it's been a bit longer now. But this is, if you want to do Android development, you basically need to do Kotlin. So 80% of all the Android applications are actually written in Kotlin, and the other 20% are probably very old. Just my guess. That's not. I don't have numbers on that actually. But most of the development actually goes towards Kotlin, and there is a good reason for that. And I'm going to list a few of these reasons. So yeah, also there's a very big community, which is really cool to be part of that community actually. So Kotlin is a very modern language with a lot of features, and I put 3 points here, which is it's very concise. So the language has a lot of features that makes it very easy to read and write. And it's a safe language, and I'm just going to use 2 examples here. So basically, coroutines is a very safe way and a very easy way to do concurrency. So that's a really cool thing. And the other one is actually null safety. So basically, if you want to have something nullable in Kotlin, you actually need to state it to be nullable. So the famous null point exception that happens in, well, a lot of code, I guess, it's not impossible, but, well, you need to be very, you need to do a lot more wrong than you had to do wrong on Java, for example. These features are not necessarily new, but existed in previous languages before, well, but they were used as an inspiration for Kotlin. Yeah, then Kotlin offers the functionality why Compose is actually that great tool that it is, and that is the intermediate representation compiler, which allows the Compose plugin to do a lot of magic that would be very annoying and difficult for developers to do in the background. We will get to that a bit later again. Then we have function types, which is, I mean, just functional programming, but it makes it a bit easier than it is with plain Java or other languages. It's not a purely functional language. It is very much object-oriented, but it enables you to do all the functional stuff if you want to. And there is the trailing Lambda syntax, which is actually something that is very important and that enables you to write a DSL-style syntax. And that's what's used in Compose. And what that actually means, I can quickly show you. So let's see. That's the first part of the live programming. So, well, function types, very simple. Okay, we just have a variable here that has a type which is a function. So it does not take any parameters and it doesn't return anything, but you can actually invoke it. So yeah, that's very much the basics. And then this is the example where you could have one input string in that case, just some text, and you return a Boolean. In that case, that function could, for example, look something like that. So validating some input, if it's not blank, you could do it like that. And where the magic now happens is basically down here, where this filter function is. So that's just a basic function that takes two arguments. The first one is just a list. The second one, a list of strings. The second one is a predicate, which is, if you look at that syntax, the same as that above, which means it's a higher order function. This function takes another function that is evaluated somewhere down here. So we iterate over that list and execute the predicate on that. And if that predicate that returns a Boolean, if you don't follow, doesn't really matter, just for the programmers here. So if that function returns the Boolean, if it's true, then we add it to the new list. And if it's not true, we, well, just skip it. And the cool thing now is that you can actually do something like, so just declare a list and put some strings in there, and that we put into a variable, and then you can do we can call our filter function that we created above, and we put list in. What did we call it? List of, what a great name for a variable. And that is what I actually wanted to show you. This is the predicate. So we can move it out of the parentheses, and it's considered a parameter to that function. And the cool thing is that it actually is some kind of a body now. So you can yeah, have this very DSL style syntax in your code. And we're going to see that a bit later in code.
But also, we don't know what's DSL.
Oh yeah, that's a very good question. I actually thought about that and I didn't explain it because it didn't came to my mind at that point. So I'm going to skip here. No, the idea behind DSL is, I don't know the abbreviation, but it's basically that you have a programming language that is kind of, you use that programming language, Kotlin, to create another programming language on top of it, kind of, and which allows you.
Language, right?
Sorry?
The domain-specific language.
That one, yeah. So which is well, a programming language that's on top of that programming language, and that is very much built for your specific domain and your specific problem there. Yeah. And our domain is UI development, so let's get back to that. Yeah. One cool thing that you now have Kotlin in the UI and in the code that controls the UI is that removes a few boundaries, which is usually removing boundaries is often considered a bad thing in software development because boundaries are important, and that is very much true. But in that case, there was a problem because there were very few specific things in Java or Kotlin that you couldn't do in XML, but it would actually belong to the view, and that is actually something that is broken up here now. That's really cool. Moving on, different platforms. That one we can do faster. I said the future of Android and much more. Future of Android, this is basically the first row. So Jetpack Compose is on Android. It's stable release. It should be used by everyone starting to develop new Android applications. Probably not going to be, and there are a few, well, things you need to keep in mind, but still, that's the new shiny on Android. But there's also Compose for desktop. So while Jetpack Compose on Android is developed by Google, Compose for desktop is developed by IntelliJ, so the developers of a Kotlin language themselves. And you can actually write desktop applications on Kotlin, in Kotlin, in Compose, which is a really cool thing. It's still in alpha, so the API is going to change a lot, but it's getting there. And the next thing is that this also exists for web, which is like very cool. So if that actually turns out to work at some point in the time, you can, well, gather your skills on Compose and actually use it in all these different platforms. And there's also a little gimmick. Well, it actually works. So you can also use it to write some UI in the console. So to have a console application that actually offers some kind of nice user interface. And that was more or less written as a proof of concept that Compose is not just the thing for Android, but it's actually a very cool thing that is capable of much more than just doing Android UI. So a really cool project. It's open source on GitHub. If you're interested, you can find that there. Okay, the next topic would be declarative and reactive. Okay, declarative. What is a declarative UI? So the clue is in the name, and I mean declarative UI is very much a buzzword which is used quite a lot recently. I just wanted to briefly give you an overview what's meant by that. And the best thing to do here is probably compare it with an imperative UI, and the UI system on Android before Compose is very much an imperative UI system. And that means that you have your XML, which defines all your views and everything in there. And then you actually, in your code, need to find one of these parts in that view and act on that. So if something changes, you need to find that specific thing that could be there actually. Maybe it's not there anymore because you removed it in the step before. So that's kind of dangerous there. But if it's still there, you can actually act on that. And that is very much simplified imperative UI. And what in the opposite is the reactive UI. The declarative UI is where you actually declare how your UI works, and all the magic, how that actually is converted to the views that the user sees, is done by the compiler. The compiler does the heavy lifting. You just write your normal code, and you describe the UI, and that gets then translated to the views. Probably is going to be a bit easier to understand once we actually look at the code. So one thing with declarative UIs is that they need to change whenever the data changes. So you have some function somewhere that is called and creates your UI, and when the data changes, all the UI needs to be re-rendered. And that could be very computationally heavy, because just creating the whole screen from scratch is actually quite heavy lifting. And that's also where this compiler plugin from the Kotlin compiler comes in play where it actually tracks which data changes and only changes these parts. But that's actually in the next slide. Just wanted to point out that Declarative Ui that has not been invented by Compose. That's very much a thing, and it's all over the place. And Compose just well, they didn't copy it, but they took some inspiration from other languages and built on that. So there is Flutter, there's Swift UI, there's React Native, and yeah, there's quite a lot of that around. And yeah, so not a new thing, but actually a new thing for Android. Talking about the recomposition. Recomposition is what I've mentioned before. That's the potentially expensive part. So if you are not very smart about that, you actually need to recreate the complete screen once something changes, just to make sure that everything is still rendered in the way that it actually should look like. And yeah, that is where the intermediate representation compiler plugin comes into place. So the Kotlin compiler has a Vue extension points where you can actually add a plugin to it. And the Compose plugin is, well, one of the more complex ones, and that actually keeps track of all the changes in the view and where actually the data could change. That's quite a complicated thing. And they, in this intermediate representation, they generate some code to your existing composable functions, and that code is used to, at runtime, track what's actually changing, and that code decides if that composable function should be re-rendered. Okay, finally some code. How does a composable function look like? So I told you a lot about composable functions. You haven't seen one, so here is one. So a composable function is basically, it's just a function that takes in some data, or even it could not take in some data, but in general it takes in some data and it converts it to UI. In general, these functions do not return anything, so it's not your typical return a view as you would probably expect from Android, but it emits the UI, and that is again where the compiler plugin comes into place. That's all done in the background. So it's kind of a pure function from functional programming, but not completely, because in the background actually you're mutating state. So it's not completely a pure function, but you can have some of the assumptions from pure functions applied to your composable functions. Another thing that probably jumps your mind, and if you're into Kotlin, you maybe don't feel so good about that, is that there is actually an annotation about your above the code, and that annotation, if you worked with Java, annotation processing is a very expensive thing. Good thing here is it's not actually annotation processing that's going on, but rather this is just used for the compiler plugin to decide, to know that this is actually a composable function, and that allows you to pass the data down the tree, the UI tree that is generated. Okay, so the function is actually the replacement for the old Android view. So where you had a view before, you now actually have a function, and this function here would, for example, show some text on the screen that says hello, whatever the name is provided here. And the cool thing, if that name changes somewhere in the background, this function knows about that magically, kind of magically. We heard about the compiler plugin. But for you as a developer, you don't really need to care about that. And that re-executes that function and, creates the UI for that. There is one very important thing here to mention. You shouldn't really do any coding. You shouldn't have any assumptions about when this function is actually called. So just doing some computation within that function would not be a good choice. So your mental model should always be, okay, that function can at any time be called by the Compose system and generate that view But so therefore you need to be kind of aware how you write your code. So that's basically the most complicated thing when you get into Compose. Okay.
Looks pretty much similar to Flutter here.
Yeah. That is the thing. So that's not a completely new thing. So there are a lot of frameworks out there that work similarly, but for Android it's very new, and also I think it does a few things different in the background. Okay, so quickly talking about Jetpack Compose on Android. So up until now that was very generic. That was Compose on any of the platforms I mentioned before. Now let's swiftly move to Android for a bit. So interoperability is a big thing. If you already have an Android application in the store, for example. So if you're lucky enough to start a new project, that's fine, that's cool. Go for it. Jetpack Compose, and you can just go with it. But they also offer very good interoperability. So you can have your normal activities with your XML and have some Compose component in there, and also the other way around. You can have the completely composed UI, and at some point have some legacy view in there, which is even more important because there are quite a few libraries around which will probably take some time to actually have the composable API available. Fight, you stop me if I'm over time, right? Cool. Great. Yeah, so that's to tell about interoperability, difficult word. Okay, tooling. I mean, that's a cool thing because that language is to a big part, or Compose is to a big part co-developed by IntelliJ, and those are the people who actually do the Android Studio, which is used to develop Android applications. So they do the tooling. So there is a lot of tooling in place, and there's really a great, really cool helpers that really get you starting easily with Jetpack Compose. I'm not going to list all of them, but some of them we're going to see in the live coding, well, short live coding, I guess. But yeah, we're going to see them. So for example, the Composable Preview is a very cool feature where you just immediately see that composable on the screen. And I think, yeah, that's the part where we jump into the code. And I also think that it's probably a bit late took me a bit longer than expected actually, so let's go to the cheat version. Okay, let's just ignore that for now and switch to that and have a look on what's actually going on here. So we have a welcome screen here. So the idea is that we want to just present a screen with a title in there, an image, and just see what's actually going on there and how you actually write Compose UI. So let's start simple. Where is simple? There is simple. Okay. So we have the title function here. This is a composable function. It needs to be annotated at composable. Otherwise, the plugin cannot inject all the necessary information. So if I remove that, IDE is going to scream at me. Yeah, cool. In there, we have one of these elements, which is a provided element by Compose actually, and this is a text, just a simple text that we're going to render on the screen, and it says, well, hello name, so the same thing we have seen before. There is a bit more here to see, but we just ignore that for now. So we have some text. That is probably a bit, so we now actually want to see how that looks, and we're going to add a preview to that. So let's be cheap and just copy that, give it another name. Okay. And some closing brackets, and then we go title preview. And that's actually already one of the tools that I wanted to show you, and that is the preview. So let's quickly show that again. Well, it would be more impressive if there wasn't already something else here. But yeah, that's the preview that we just created. It's just empty, there's nothing in there. So let's add the cheat title and well, be creative. And that's something that's still a bit annoying. You need to rebuild that quite often, but well, they're working on it. But now you actually have this very nice preview of what you created there. So that's a very simple thing. Now, if you would like to have a second text, for example, it gets a bit more complicated. Yeah, a bit more complicated. Now we are where we wanted to be. Okay, now we have two texts, and surprise, nothing really happened. And that is because it's actually just rendered over each other. So we have no layouting in place. It's just, okay, there's one title, there's the other title. You can probably change this text to by, and you should see it if all these go away. And it does rebuild. Okay, yeah, that's the pain of live programming, right? Okay, yeah, this is just rendered one over the other. And the idea is here that we now apply some layouting. How much time do we have? 5 minutes?
Yeah, 5 minutes.
Great, that's cool. Just stop me if you're not interested anymore. Or actually don't. Okay, so what you've seen here is now exactly what I showed you before, this DSL style this DSL style feature from Kotlin. So this is actually just a function that takes a lot of parameters, which we are not too much interested in, apart from the last one, which I cannot scroll down to, unfortunately. Well, okay. Apart from the last one, which is a function type. So this is a higher order function, which the last parameter is a function is of a function type, and you can actually and that function type is actually a composable function type. So that again takes composable elements, and we can just move them up, and they should now be displayed one below the other, or not. Well, great, cool. That's very unfortunate. Okay, just ignore that. That should now be rendered one beneath the other. It could be that I need to rebuild, but in presentation mode I don't really see that. Never mind, we only have 5 more minutes, so let's swiftly move on. Another important thing that you can do is that you can modify almost any view, and that you do with a modifier. So almost every element that is available, and also the elements that you're going to write, because you're going to compose your own functions if you do compose. So for example, the cheat title is just another composable. It composes 2 texts in a row, so which these should be one next to the one after the other. And if you define something like that, you should actually consider taking a modifier into account. And that modifier gives you opportunity to apply padding, shapes, colors, background, whatever. And that modifier is basically there to provide all these functionalities in a more concise way. So otherwise you would have to have all these different parameters in there, and you would probably end up with a very long list of parameters. And well, you can avoid that here by just having these modifiers, and that pretty much changed. So we have a padding here, and we can actually, for example, also add a height, a specific, and so on. So that just changes, and yeah, it's better readable like it is now. Okay, so let's quickly recap on the things we've seen. So we have layouting. There's also obviously a column. There is a box. There is a constraint layout. So there's a lot of different layouting available, and yeah, it pretty much ticks all the boxes that you need. Then we had the modifier to add some styling information, a padding, a height, whatever you need. And then you can do a lot more. For example, theming. That's a really cool feature. Unfortunately, time is almost up, so I'm just going to jump back to the presentation and give you a short overview here. So, okay, layouting we already had, modifiers we briefly covered, theming, very cool thing. Jetpack Compose comes out of the box with a dark and a light theme. So every app that's going to be developed on Jetpack Compose will also support a dark theme, because it's just it's already there. You just need to define the colors that you want to have to be used in the theme, if it's on light or dark, and it's just applied. So really cool. Works really good. Best practices we're going to skip. No one needs those. And that's a very important slide, and that's about, if that got you interested to some extent, at least, then these are the resources where you can actually get into it. So there is specifically there is the Compose samples, which is the official Compose samples, which tell you how a complete application should look like. So how should I structure that? How does that play into another? Where do I put my business logic? Where do I actually put my views? And so on. The Kotlin lang Slack is actually just the JetBrains Slack for the Kotlin language, has a specific channel for Compose, very supportive community. If you ask something there, usually within a few minutes you get a good answer there, or at least a link to where you can look it up. Also, the official Jetpack Compose documentation is in place just on the Android developers page. And then there is a very useful tool, the Compose API guidelines. That's, my time's up, I know. That's where you get the best practices that I just skipped. So if you actually want to write some good code, look at that. Yeah, and then that's the deep dive. If you actually want to know how all that state management comes into play. Yeah, I would need another hour. Is that fine? Yeah. No, thanks for your attention. Actually, really enjoyed it. I hope you got something out of it. Thanks.
Just stick there for a brief second.
Sure.
So if there's any questions, we still have a little bit time. Sorry. Very stupid of me. Now, yeah, I'm in frame now. So questions from the audience?
Is there also some kind of graphical UI editor, so that you first design the UI and then generate the code out of it?
Not yet, and I kind of doubt that this is going to be in place, but don't quote me on that. But it's kind of easy to get into it, so because you basically if you start Android Studio, and I can use that time now to get my other slides in. If you start Android Studio, you can just create a new Compose application, which comes with a pretty nice template, which gets you started. And there's a lot of documentation out there. So if you have some programming experience, you should be good.
What is the output of this compiler? A bytecode which is interpreted by Java, or does this?
Yeah. So the IR is an intermediate representation, which is something internal for Kotlin, where we actually just do some optimizations basically, and then you can also do whatever Compose needs there, and it basically compiles down to the JVM. Yeah. So at least for now, they have. Well, it is technically possible to also compile down to native, and Kotlin is very much capable of that. But for now, all the mentioned platforms are compiled to the JVM. So memory management is the JVM memory management, what you would expect.
Okay, any other questions from the audience? Then I have actually one. So you said that you're not professionally working on this. You also said that this is kind of a pet project.
Yes.
Do you have an example?
The pet project? I do have one example, but it's like a very specific use case I'm covering with that. So you all know that there is this pandemic going on, or has been, or is still probably. And my wife and I actually my wife had the idea to have an app where you can look up your local farm shops. So you don't need to go to the supermarket where you, well, meet a lot of other people, which was, well, to be avoided at that time. And so we developed that, just a simple list with the farm shops in there that you can just scroll through. It's only for, well, East Tyrol, so probably not too much interesting for the audience here.
How long did that take you to develop the UI for that?
Actually, pretty fast. So all in all, it was like 20 hours, something like that, 20, 30 hours. For me as a complete, well, I did another pet project before that, but still, that was when the API was still in beta, I think. So a lot of changed, and every update was well, pretty breaking. So yeah, but for me, it was really easy to get into it, and it's well, it's easy to learn.
Okay.
Once you have the mental model of, okay, that function is called whenever it's needed to be, and well, I need to modify my state in that way.
Okay. Yeah. Well then, thanks again for being here and inviting us. I would suggest a quick pause, at least for the YouTube audience, so that we can switch speaker, and in between, feel free to grab some drinks. Afterwards, there will be some pizza, so that is also one of the perks of being here live.
You can still join if you're fast.
And there's another small thing. So we would like to take some pictures. If anyone does not want to be on any pictures that we would publish also, just for this event, please let me know so that you're not on any of those pictures. If not, thanks. And with that, I would suggest that we quickly switch and you grab yourselves a drink or have a quick chat.
Ja, aber auf Deutsch. Das wird spannend.
Alles Apple.
Ja, diese Frontend-Leute mit den Apples. Na, aber da hast du das Beste, oder? Du hast gerade für Designgeschichten und so weiter, ist es eine wunderschöne Oberfläche, und für Coden bis zu nah an Linux, also gerade von den ganzen Dingen.
Wobei man sagen muss, dass Windows mittlerweile mit der Ubuntu,
ja.
Der Ubuntu-Portfolio
Okay.
My name is Ima. I would like to ask you maybe a question, if it's possible. So, did you work with Flutter?
No, I haven't actually. No. I would really like to, but I haven't had the time yet. So yeah, this is actually my first contact with Reactive. Oh, well, I did Vue.js at some point. Do you know Vue.js?
Yeah, but I also didn't work with it. But currently, I'm doing some work with Flutter.
Okay.
But I'm just asking the question because I don't know why anybody would use anything else as Flutter now. Because I don't see, if you want to develop a cross-platform, I don't see actually any benefit of, because it has amazing features. I'm doing very specific things with that. I'm able also not only to execute native code in Java, but also get native views from Java and hosting them in Flutter code.
Okay.
And
am I right that Flutter actually renders its own views?
This is true.
This is like one of the arguments that I usually hear when that is discussed. That's obviously a discussion that is well, pretty frequent. because it's a valid point. I mean, why have another thing that's only very specific on Android and not just go for Flutter where it also runs?
Exactly.
Yeah.
And especially when you want to develop something with iOS and you don't want to manage multiple codes and even talking about rendering, this is metal and this is, I don't know, OpenGL. A lot of headache.
Yeah.
A lot.
I got you there, yeah. So basically, the one big argument is the native UI.
My question would be why, what's the benefit of using
Gut aus. Maus. Na, du brauchst noch nicht.
something that's
Output haben wir noch keinen?
Output haben wir noch keinen? Ah ja, gut. Darf der Fernseher
Really
noch?
good question.
Fernseher läuft noch, ja?
Actually, I don't have sufficient knowledge about Flutter, so
Machen wir mal
starting
den klassischen
answering that.
Fuß aus.
But I think that Kotlin will also Compose will also go in that direction. You have already seen they have desktop, they have web, they have a console. So it's a very powerful system, and they're building it out. And I think
is it by Google?
Jetpack
Hat sie nämlich erkannt,
developed by Google, and it's basically co-developed by the multi-platform stuff. So they do the desktop stuff and the web stuff. So that's basically where that comes from.
Okay, so it's a fight. It's kind of a fight right now. And also Flutter, it's from Google, so I don't understand.
Yeah.
They have different departments, it seems, and they are just looking and seeing who is going to succeed more than
Jetzt aber.
Yeah.
Jetzt kommt auch was.
Na komm
It's
mal.
not even another company, it's the same company.
The same company, yeah. I guess competition is always good because they learn from each other.
Auch noch ganz kurz nutzen.
And
Also wenn wir auf jeden Fall eine Pause machen.
I have read a really
Muss
good,
ich auf die Toilette noch von der Aufregung?
really good Reddit comment on exactly that topic. I don't really recall everything of it. But Jake Wharton, you know, the Android guy or Android. So he has a really good explanation about it. Maybe I find it if that's the case. I'm going to send it to you. Are you registered?
Yeah, I'm registered. Yeah.
Okay, then I can maybe post
Find
it.
it. Yeah.
Cool.
Perfect.
I'll have a look. Yeah.
Thank you.
You're welcome.
Na?
Ui, was ist nicht? Die Hauptsicherheitshalber, ja genau.
Und? Pipi-Pause.
Okay, so let's continue, and I have the pleasure to announce Sven, who is going to talk about Angular mostly.
Yes.
He is front-end tech lead at Anexia. We're very happy to have him, and we're going to expect a great talk from him.
Hopefully. That's it.
I'm sure. I'm absolutely certain.
All right. So, yeah, welcome to this nice place. Thank you for the invitation and the possibility to speak in front of you. I'm quite nervous. I'm not used to speak in front of thousands of people. So, it's like the Angular conference now for me. Yeah, not much to say about me. I'm technical front-end lead at Anexia in the software integration department. That means that we make customized software for clients. So we don't have our in-house products or something. We are basically fighting at the front. Clients coming with requirements and their own APIs. And you need to get some kind of creative. And this is what this talk will be about. So it will be the contents, just 4 points or 3, because the Q&A is your part. Most important question, who is into Angular? So basically, who is experienced Angular developer here? All right. Who is quite novice? So I just get the feeling how much time I will spend to explain certain terminologies. All right. So I see half of the 600 are, Team Angular, great. All right. So I will speak about, and I will call it, so it's a name I'm giving them, DataAccess Modules. So Angular basically is a component-based framework, but it's structuring or grouping these components into modules. And speaking in the manner of data access, it means everything which is talking with web services out there. So we are speaking of our front-end application, and this somehow needs to fetch data from a server, get data from a server. And in the domain-driven design universe, they are called data access parts. So I call them data access module. OpenAPI. Who knows about OpenAPI or Swagger? Good. So I don't have to see the Wikipedia. Nice. Good. So I won't stop here and move on. So for those of who never have seen such a documentation which is pumped out of Swagger or OpenAPI, this is how it looks like. And yeah, of course, maybe the audience on YouTube is not aware of OpenAPI, so I won't skip them. So this is how it looks like. On the right side, in these beautiful colors, we have our request types, basically put request, post request, or get request, and endpoints listed. So they get colored based on the type of request they are. And they basically give us the documentation about the web service which we're going to use with our application, our front-end application. So the status quo basically is the following. We have a backend team, and they're coding their API, the REST API, the web service, and they're providing us a documentation which the more experienced one will generate out of their API, and the less experienced one will maybe type this documentation by hand. And now we have the front-end team, and the front-end team will request this documentation and will try to read it, understand it, and try it out, and start typing in the front-end code to be able to communicate with this API. So if we look at this kind of process, we basically have two teams or two developers or a bunch of developers, which basically are doing the same, just to get to know each other and be able to communicate with each other. We have work which is done in the backend, which is typing or specifying and documenting the API, and we have the front end, which is basically copying this documentation into the application to be able to just communicate with this API. So, demo time. A lot of live coding today. Usually in Angular, it's done by creating a service. I will call it the pet service. And it's decorated, it's decorated with an injectable. So live coding, zack, zack. Oh, great. All right, so I'm a fast typer guy. No, so basically I will explain you the code. So on line 6 you see it's the injectable decorator, and it basically marks the service. The service is this class, and the service basically is something, a class which holds some logic. And it's decorated with injectable, so Angular provides dependency injection, so I'm able to, at any time given somewhere in my application, to take this service and inject it into my component. And best practice, or most practice, when you go out there and watch some tutorials, you will see they're implementing a component, and then they are providing some service, and then they will communicate. They will inject their own service, which is called HTTP client, which is a service on its own, and then they will show how to communicate with the backend. And I think I skipped something. Yeah, maybe let's move back. For sure, you will be curious why there's get pet, so maybe we go back and clear our plan. So this is the Swagger pet store. And it's something which you can find on the website of OpenAPI or Swagger.io. And basically it's a demo store with demo endpoints which you can call in the browser via this editor, or you can directly write code and test your front-end application against this pet store. To the left, we see our Swagger specification or OpenAPI specification, but this is specified in Swagger. Still, it's written in YAML, the YAML format, and to the right side we see our interface. And my plan is to access this API, actually. So I'm writing this pet service to communicate with the pet store. All right. And the first thing I want to implement is the get pet. So let's head back to the documentation. Where is it? There's just a get pet find by status endpoint, status endpoint. Great. But in our fictive service, we will do just get pet to describe how it's usually done. So for communicating basically with a web service, I will have to specify some headers. So first my method, some headers, and I will have to specify an URL which I want to point to. So which URL I want to call. And I will return, delegate this to the HTTP client, which is a service provided by the Angular framework, which exposes common communication pattern for calling web services. And in this special scenario, we have a get method which gets called. So this is how it would be done usually, but it's still missing something in our implementation, right? And I think it won't scale that much if I will have to specify my HTTP headers on each call I'm doing and injecting my environment, stuff like that. So we could improve this call. And let's see, in this improved call, I've added a loading observer. So I want to observe if the request is still pending, because I want to show it into my component. So my front-end component wants to show a loading spinner, so I will need somehow a state which represents the status of this network request which goes out to the web service. So I have a loading state which I'm handling here. I'm injecting a logger, URL prefix, service, a cache, and stuff like this. So this is how you, maybe on more advanced applications, you will see this kind of service implementation. They're already trying to separate things by injecting other services and basically, basically separating stuff. So when we are working with Angular and components, and we are writing basically TypeScript, and we are using TypeScript because the base language is JavaScript, and JavaScript is not typed at all, so just plain objects flying around and functions. And to get lesser bugs or something, TypeScript came up, and now we are able to write interfaces. So we are not anymore kind of blind about which data objects we are shipping around, but we can write interfaces. So we get basically autocomplete in the IDE, and TypeScript will help me also showing me on compile time that stuff is broken if I'm not following the interface which I'm implementing against. So many benefits with TypeScript, but I have to type that by hand. And now we see that this getPad method of this class service, just one endpoint gets huge, actually. I need to write interfaces about the response, type it and write code. I need to prefix and use my URL helper. I need to manage the loading state. So initially the code will be that the state is not loading at all. But then when it starts, I will map it to that it's currently running, so it's loading. Then there would be our HTTP client call, and I'm managing here now with RxJS the loading state, the logging. I'm doing also some kind of caching and also error handling. So we got now about 75 lines of code just for one endpoint, and somehow this doesn't feel right. Yeah, it's somehow a lot to type, but at least we are type safe. We can write tests against it, and we have some stuff which is using dependency injection and works in our component. So most of developers will be quite happy, and maybe if they're not lazy, or if they're lazy, they start to extend a base. They will try to do something like a base HTTP service where they abstract the loading state, the caching, and all the part into this. But yeah, somehow this does not scale anyhow well because I still will have to map the request and the response. All right, so it's the status quo of Angular implementing HTTP. Of course, you can do it. It's a little bit polemic now, but or spoiling, but let's move. Woo. Here we go. Any questions till now to the live demo? All right, let's move on. So to sum up, it's kind of time consuming because I have to type a lot. It's repetitive work, so I have to do stuff which already the backend team did in the documentation on an API. I need to track my interfaces by hand. And somehow it's lacking of flexibility when I start to use something like this base service in TypeScript, since we can only inherit from one class. Pros would be I'm the controller about my code. I'm able to explicitly define what I want to send to the server and what I'm getting back. And maybe I have something, also the subjective feeling of having something to do, because spending the next 2 weeks writing 300 endpoints and stuff. All right. So maybe a more pragmatic approach, and that's why I'm here today, would be if our backend team would write their documentation with the OpenAPI standard. Then I would be able to generate from the specification my complete service models, interfaces, and stuff, which I need to communicate with the backend for Angular as a module. So, demo time. For those of you who are interested then in this demo stuff, at the end you will find a QR code. You can scan it and it will bring you to the GitHub repository where the slides are, where the whole code repository is there, also with the ugly pet services, which are prepared here. So, lost my mouse. Great. Good. Let's close this, guys. So what does it mean? I will show you. Zip, some scratches here. All right. So to the left, there's the file explorer of my EDA, and under the directory tools and bed store data access generator, I've set up a little tool. So just to be able to generate basically some code with the Open Generator CLI. So usually I could call only OpenAPIs generator CLI generate. It would be enough, and specify where my specification file is lying. I've wrapped this now into a package, in a node module package, just for the sake to be able to run it with npm. So this is our artifacts directory, or folder actually. You don't have to call it artifacts at all. I just call it for the reason of the purpose. And inside the specification, actually, there is this pet store, which I copied from the Swagger OpenAPI. I have it in JSON because I'm a JavaScript front-end guy and I love JSON. That's why I don't have it in YAML here. And to the right, you basically see the same interface. My IDE is able to, thanks to a plugin, to display this specification. But this is just the part where we say, okay, I want now code. I want to have my services, my model, my interfaces, everything generated out of this specification to be able to use it in Angular. And everything I would have to call is npm run generate, but it's not that magical. I specified also, or added an OpenAPI tools JSON. It's basically a configuration where I configure the Open Generator CLI, OpenAPI Generator CLI, what I want to generate out of this. And I want to use the generator TypeScript Angular. I'm defining my output path, which is the current directory with artifacts and the pet store. And then I'm adding some additional properties like the Angular version I'm planning to generate this module for, and maybe some name for the npm package. So let's see if it works. Wait, just press enter. Ooh! It did not. I'm in the wrong directory. Nice. So once again, npm run generate. All right, and you will get, it's quite verbose actually. You can do it also more verbosely if this even existed as terminology, where you can check the specification against the OpenAPI specification and see if it's still valid and stuff like that. But when we take a look at our artifacts directory, actually folder appears, it's called pet store. This maps to my output path, which I defined here to the right. And everything which I have now inside is all my models which are used inside the pet store, which got defined in the specification. Of course, some of them are not huge at all. Maybe there's the order, which is a little bit more complex in its structure. And then the next thing would be that I've got every endpoint basically grouped by its tag to a service, which is injectable. So I get all my heavy lifting, like writing and doing best practices with HTTP params, overloading of basically endpoints and their parameters, and all that I get generated out of the box. And now I can use it as a package inside my application, inside my Angular application, because it is structured. It is structured like a usual Angular npm package. So I could publish it inside a private repository like Verdacho, or I can go publish it also to npm. Doesn't matter. Or I could choose the way or the path which I did now. I made a tarzip file by running npm install, build, and all that stuff, and I got my package inside a tarzip. file. So, funny thing is now I can use it by my application by just pointing inside npm by using the file property. So I say I want to import my PetStore DataAccess module from file, and it's located under packages PetStore DataAccess. If you want, we could also run the packaging and installing process with npm, but this talk is somehow not about this, how to make npm packages. I will skip this part. Now back to our beautiful application. I will remove this ugly hand-by-hand written stuff and move to my app component, which in this special case is the root component of my application, so Angular, we start there. And what we can see here on the imports is that I'm already importing a service, the pet service, and the pet from this PetStore DataAccess module, which I'm generated before from the specification. So this is really convenient because I get the whole thing auto-completed. I get the service interfaces, so I would be able to exchange a complete service if I'm not happy with the generated thing. But most of all, I get the interface immediately. So everything is typed, and it's just, yeah, it's the end application. So I will move back because it's not all gold what shines, they say in Austria. All right. So there are some cons. What if we want to change something in this service? So a pet service is not doing that what we want. So somehow it does not feel well that we modify generated code, right? You don't do this because next time someone generates, your modifications are away. And the backend must provide an OpenAPI specification, which is not always the case that you're able to get this as a front-end developer. The pro points would be time saving. I get all my interfaces. They're really doing this what the specification is saying. And I'm able, thanks to node modules, that I'm able to version my package. Every time I generate, I can make a version and use it in the front end with different versions by just running npm install and stuff like this. I reduce typos, and it's somehow generic, maybe we call it like this. And I get kind of easy migration because it will fail on build time if my interface is not anymore in sync with my application. All right, let's go to the con. We must modify generated code. So do we really need to modify this service? I say no. Why? Because we are only interested in the request and in the response, which this service is basically providing for us. So we are delivering a request into the service, and we are interested in the response. And Angular gives us the power with an interceptor to actually really catch only the request and the response, which is going out. And so I could intercept the generated code without actually going there and changing my service, because I don't have to touch it. The code which got generated is just there for communication purpose, but not for maybe shipping my business logic. So, of course, maybe I don't want to intercept, or so I don't know. Who is aware of interceptors? Who knows what an HTTP interceptor in Angular is and how it works actually? All right. Ooh, just 50. All right. 600 to 50 people. So I will explain shortly what an HTTP interceptor is. We have our component, our Angular component, and it's basically consuming a service. This is what we did for before, this pet service which we have written, which was ugly. And this was injecting another service, which is the HTTP client. And this HTTP client from Angular is designed that when you request a method like get or post, put, any request which goes out to the web service, it will provide you an interface where you can catch this request which goes out through a service which is called Interceptor. You can define your own interceptors. And since it's stream-based, it's an observable, you will have to do only with one stream. And the stream will have an HTTP event, which is the request, and an HTTP response, which will be the response from the server, or an HTTP error. And the interceptor allows you to just pick in time when it goes out and modify the things. And this is the pragmatic approach, because I don't have to touch the how to communicate with the server thing, but can still manipulate my thing, my request and my response. Of course, interceptors will work on any request which goes out, and somehow I want maybe to just pick one certain request which goes out. And there is it where before Angular 12 I can provide a request ID strategy. So maybe I'm providing a service to this interceptor with a certain strategy, and I will form out of this request an ID. It's not that hard, because the URL most of the times is already an ID, but it's not common to map turn. I will have some more concise examples with me. Since Angular 12, we can basically forget about request IDs and strategies about generating them. Since Angular 12, we are able to pass to every call which goes out to a certain configuration, we can provide an HTTP context. So it's quite easier to group certain HTTP calls and intercept just these. All right. So the backend client must provide an OpenAPI specification, would be the second con I went up with. And that's not really true, because if we are in a special scenario with maybe they're delivering a Word documentation of their API or have anything else, I don't know, I've seen a lot. I was in Paint. And so there's anyway doing things by hand process. And why don't just, if you're already porting this unportable documentation to code, why don't you just port it to an OpenAPI specification and then generate the code out of it? So it would save interface time, it would save service time. If you're concise with yourself, you will say, okay, I won't code this anymore, I will maybe specify it and bring it in this. You need to have the documentation. That's right. That's right. But how it's now, how it's done today is developers see their code not as kind of documentation, but if we abstract this somehow, the service which they are implementing to communicate with the HTTP is a kind of documentation how to communicate with this web service. And they say also kupft wie Katsch, so it's jumped like walking. Yeah, it would not change for me if I start the code to write the documentation in the specification format and then generate the code, because maybe Angular will change, maybe my front-end technology will change, and thanks to the OpenAPI generator, I'm able to pump it out for React, for Vue, for Svelte, for any other format, but I still have my specification. So you could do the nice lifting, which maybe the client is lacking of. All right. So in a nutshell, if we look at Angular and their concepts which they are providing, I've marked with a red circle the part where the HTTP and its interceptors are working in the whole thing. So we have two layers, basically the data communication and the data view and interaction. And if you keep things separated in this way, basically you're getting really a nice developer flow, and also you get a clean architecture in your application. You can get this diagram later on the GitHub page. Good. There it is, the QR code. I bet I forgot something, heading over myself. I generated this one with OpenAPI, by the way.
So you showed that it worked with the REST API, right? And does it also work with the GraphQL APIs? Does it also generate something usable?
I guess the way how GraphQL is working, actually, you won't be able to generate modules from there because the feature of GraphQL is that you are writing queries in the frontend to the backend, so there won't be any specification which is able to generate for you the service which you want to address. So yes, in this case, it would be for RESTful web services. Of course, I saw also in my career stuff like, I'm now since 7 years with Angular, I saw approaches like hiding GraphQL behind a REST API and stuff like this. All right. Good. Any more questions?
Do you maybe have an example for a use case for the Interceptor?
Yes. Oh, thank you. I think I skipped this one. And I skipped it really. Thank you for showing this. I've prepared basically, I call it a registry loading interceptor. And it's basically a registry which is providing me observables of loading states for any request which goes out. What this means in practice is most of the time when we have to do with components in the front end, and data which is coming from any web service, we will have time to wait and show it to the user in kind of loading spinners and stuff like this. And this registry is basically Interceptor which maps inside or hacks in any request and provides, based on the request ID generator strategy, which you define, so you are able to hack inside this registry and to say, okay, I want to identify requests based on my own logic, or I use the logic which comes with the registry loading interceptor. And also there is a request filtering strategy which you could provide if you want to do it blacklisting instead of whitelisting. So when you're working with interceptors, your main concern will always be how to identify data in a stream, or requests and responses. And it's just a tiny part, actually. It's not a rocket science. But this registry loading interceptor basically is an example, a code example. You can get it. It will be also on the Hacktoberfest next month. I will flag it, and you can look into it. I think it's not that good documented. It is. There's good documentation, and yeah, lots of fancy words like request ID strategy, maybe, or request filter strategy. But there are more patterns, actually. I'm always trying to provide first interfaces and code against interfaces, then you get the ability to make it thanks to Angular and their injection, dependency injection thing, you can make it customizable to the outside. So this would be an example. Maybe I explain it. So we have a component, and this component is subscribing over a facade, which is a kind of service, which is hiding all the implementation. Yeah, it's gone. So it's hiding. It subscribes to an observable, which is, and it's expect that it gets a true or false. So an observable which maps to true or false. Based on this, I will hide or show in the front end the loading spinner. The facade will, thanks to their request ID strategy, which they're using, subscribe to the loading state. And the loading state, usually people tend to use NGRX or NGXS or any Redux-style pattern. It doesn't matter. You could provide your loading state also with one of these state libraries, but you could do it also plain with RxJS to have lesser overload in the libs. And this loading state basically gets managed from the loading interceptor. Should I show you some code about it, or don't we need to go that deep into how the loading interceptor looks like? Yeah? You're interested? All right. Let's jump right into it. So it's my fancy playground, the source of the registry loading interceptor. And the interceptor is this guy. I will maybe make the view a little bit smaller. So, font size Here we go. I think 17 should be fine still. All right. So, the registry loading interceptor is like any service which you want to provide in root in Angular, decorated with the injector provided in root decorator, so configured with this metadata, and it implements on its own an interface which is the HTTP interceptor interface from Angular. And all that this interceptor interface is requiring is basically a public method which is called intercept. It will give you a request and a delegate, basically, so the HTTP handler. And yeah, so we run the delegate handle, basically, and are providing a request. We are here now in a stream-based manner in a declarative universe with RxJS. And what I'm doing basically is moving this request, piping it, or giving it to the handler and piping to map this thing to an event to loading count. Yeah. So I want to track somehow how many HTTP events out there are loading currently. Yeah. So the next thing is I will map this request to my loading state. And the third thing is I will catch it on error and I will throw it on. So basically, to be in this policy of intercepting, you don't want to change something. You just want, like, I don't know if you're into quantum mechanics, basically, just the Doppelspalt effect. I will. Another thing is, you try to observe just some behavior, and the interceptor allows it. But you could also change it completely. So if instead of delegating the request, I would, I don't know, map it to some mock service or anything. But the rest is really straightforward, I would say. I have an update loading state. They're all private methods just to manage these basically three properties. A state change trigger, if some component is interested that something has happened in the network part. Then a network request counter, if someone is interested, if there are any network requests. And then basically the loading dictionary is really the thing which gets defined by you. So you could define basically your ID strategy, which maps to the string, and then the basic state of Boolean, because HTTP calls or an HTTP request can just be loading or not loading. Doesn't matter if it errored, it's not loading anymore. So it's a pretty simple example. Maybe you're interested in the usage. I provided also something in the README, you will find it. Concrete implementation would be, I'm injecting my registry loading interceptor, and I'm also injecting my request ID generator, which I configured at module stage. Because I will need this thing, because I want to have a component which starts to listen to a loading state. So I will need the ID generator, or the strategy basically, to identify this URL to a certain request. And I'm handling this to the loading registry, and it will provide me the state with the request state of loading, not loading. Then you could also do something fancy like is any loading. So the loading registry is, thanks that we are mapping how we are counting things, how much requests are running, which not. We can provide something like is any request loading at all. If I have a global spinner or something going on, or I want to log some UI elements while they are not touchable. Yes. Hope that answers the question.
The detailed answer was actually really helpful.
Thank you. Good.
Okay, then thank you again. That was a very, very interesting talk.
Thank you.
Thanks for being here. So with both talks now over, there's one more thing that, actually two more things that I want to do. The first is, could you, Lukas, please come up here again. And could you stay?
Of course.
Because said we're very thankful that you actually both joined and both had talks. So we prepared a very tiny little something. Thanks. Show it in the camera. And you'll find something in there. You could actually very quickly check. There's a towel in there, which is branded in our Lakeside Talks merch style. Yes, please. Yes. That would be awesome.
All right.
However, we are very and deeply sorry that it does not quite fit the quality of your talks.
Oh.
We're very sorry about that. The next batch will be better, and you will get the chance to replace it.
Thank you.
So next time if you're here and we have the new ones,
you want to replace it. Thank you.
And also, this will be handed out to our next speakers, which neatly gives me a transition to my next point, which is a call for talks. If you or anyone you know wants to has something interesting that they want to show us, or you want to talk about, then please let me know. The email address is on meetup.com, or you can send a message via YouTube or via Meetup directly. There's a message button. So just let me know, and I'll make it happen so that any one of you can have a second or another talk here. So thank you very much again. And with that, I think we're over with the official program. And yes, pizza should arrive in 5 minutes, so awesome. You have still some time to socialize.
Thank you, Veit, for organizing this and make it happen. Thank you.
Thanks.
Good.